everyone, welcome to my physics class participation. I am Rika May B. Saganap and I will be explaining the concept of kinematic equations. First, we need to understand the concept of kinematic equations. So, kinematic equations are a set of four equations that can be utilized to predict unknown information about an object's motion if other information is known. In the equations, we must understand first the concept of distance, acceleration, velocity, and time, so that we can easily identify the values of the given, especially when we solve kinematic equations with word problems. Starting with distance, it is the amount of space between two things or people. It can also be defined as a total movement of an object without any regard to direction. From the definition, we can identify that the distance is a scalar quantity. Next term is velocity. It is the directional speed of an object in motion as an indication of its rate of change in position as observed from a particular frame of reference and as measured by a particular standard of time. Well, in simple terms, it defines the direction of the movement of the body or the object. Next term we need to know is acceleration. It is the rate at which velocity changes with time in terms of both speed and direction. If an object is moving in a straight line, acceleration is shown if it speeds up or slows down. So last but not the least, we need to know about is time. So time is the change or the interval over which change occurs. Time is used to quantify, measure, or compare the duration of events of the intervals between them and even sequence of events. Now that we know the different concepts involving kinematic equations, we now need to know the four sets of equation that we will use. So these are the four kinematic equations in order from equation 1, 2, 3, and 4, in which equation 1 has no distance in its formula. Equation 2 has no acceleration. Equation 3 has no time. And equation 4, which is the last equation of kinematic equation, has no final velocity in its formula. Okay, so now that we know the difference between the different four equations, let us now solve a word problem.
So example, our problem is a car accelerates at 3.2 meters per second for 32.8 seconds. Determine the distance that it traveled. So from the equation, we know that our given is acceleration is equal to 3.20 meters per second square. Our time is 32.8 seconds. Our initial velocity is equal to 0 because of course it starts from rest, and our distance is unknown since it is what's been looking for. So for equation 1, there is no distance, so we know that we will not use it since we are looking for distance. Equation 2, there is no acceleration, but our acceleration is already given, so we can cross that out too. For equation 3, we have the time given and there is no time in equation 3, so it's x as well. So that means we will be using equation 4, which is this equation. Okay, so now we will just place the given. So our distance is unknown, which makes it d. Our initial velocity is equal to 0. Our time is given, the 32.8 seconds, plus, since it is what's in the equation, 1/2, copy the 1/2 from the equation, and then our acceleration is equal to 3.20 meters per second square times the time, which is 32.8 seconds. So 0, any number multiplied by 0 is equal to 0. So we will just cross that out. So it becomes 1/2 times 3.2 meters per second square. And the square, I forgot to put the square on the equation, but there is square there. So 32.8 seconds square is equal to 1075.84 seconds square. So now let us equate the equation. So we can cancel the second square in both equations. And then we will just multiply them together. So our final answer will become 1,721.34 meters. So that means that from our question, which is what is the distance that the car traveled, the answer will be 1,721.34 meters.
Okay, so thank you so much for listening and viewing my class presentation in physics. I hope you understand what I taught you, and I hope you have a great day. Again, I am Rika May V. Sagana, and goodbye.